All right, so you want to learn how to use structured data responses on an easy to build $500 DIY AI PC. Now this comes with free code samples, and we're going to dive into how to start deving on LLMs for the cheap. So you don't need to spend thousands on a cloud API credits or expensive hardware to build a serious AI application. I just built a $500 PC that runs Google's newest Gemma model locally, and it's generating structured JSON responses faster than OpenAI's. So companies are charging hundreds of thousands in monthly fees for capabilities that you can now run in your basement. So after 25 years in software development, I'm pretty blown away at what you can do and what power this puts into your pocket. So this is really becoming accessible really quick. And today I'm going to give you the exact parts, give you installation steps, and even give you free code samples to build your own AI development machine, as well as some code to get started. So this can handle production level tasks with structured data generation. Now, I'm not talking about dumb chatbots. I want to actually talk about structured data so you can actually make your application start to push data through AI and then do productive things with it. So this isn't just a fun experiment. This could actually be the start of a new idea that you have. So if you're looking to develop into AI, this is a great way to get started. So let's dive in. Welcome to Startup Hack. I'm Spencer Thompson. Here at Startup Hack, we love to train software developers in our licensed coding boot camps, as well as to build custom software solutions for companies. With a decade of executive leadership as a fractional CTO and 25 years in software development, I've mastered transforming tech teams and products. All right, so as I was saying, the game is completely changed now, and we're really starting to see that bar move down to where developers can start to dig in to build AI models themselves. Now, with Google Gemma release, we've seen some smart hardware choices. You can build your own AI development environment for $500 to $1,000. But really, the one that I'm running on today is less than $500. The one I'm running on today actually cost me about $300. But especially for generating structured data responses that your applications can use. So let's dive in and take a look at this. So let me switch over to my monitor here as we talk about these. So Google recently released Gemma 3, the most capable model that you can run on a single GPU or TPU. Now, you can run this just on GPU only, or on TPU, or even on your CPU, but I would really recommend that you grab at least a baseline GPU. It makes a big, huge difference. So according to Google's blog, the new Gemma models are specifically optimized to run on consumer-grade hardware while maintaining impressive capabilities. So the model comes in several different sizes, but I really like the 7 billion parameter size, and it's really the sweet spot. I really find that it's a lot. What I'm going to demo for you today is going to be the 4 billion parameter size, because like I said, I got this machine for about $300. I got it off of Facebook Marketplace, grabbed it. It has a 4 gig card. So a lot you can do with that 4 billion parameter model for a cheap machine. But if you step up just a little bit to jump up to about $500, you can get yourself an 8 gigabyte graphic card, and this will easily run the 7 billion model parameter of Gemma 3. So that's really this, and I find that's really the sweet spot. Now, what makes this particularly exciting for developers is the model's ability to reliably generate structured data formats like JSON or XML. Now, this is brand new capabilities that's really lowering that bar to make it so that anybody can get started on building AI. You don't have to be in the $100,000 a month range. So like I was talking about here, and I'm going to move this over just a little bit here. You can see the code that we're going to be working on here in the background. But like I was saying here, you can look at this Gemma model here, right? And this is, running Ollama. You can see that, if you want to step up to, an 8 gig card, this 12 billion model is really the sweet spot, right? So this is really the sweet spot where you can run it. You're going to need probably a 12 gig card for this, which runs about $250, right? Now, if you want to step down to just a cheaper 4 gig card, you can find these for usually in the $50 to $80 range used on Marketplace or eBay, right? This will get you started because it'll comfortably run on a 4 gig card here, right? So as we look at this, you can see, and even at the 4 billion, you can still see that you get a 128K context window. This is huge because it allows you to feed in code. It allows you to feed in a pretty large amount of data set so that every time you can be loading a whole 128,000 context window. That's huge. So the more context you can give the AI, the better off it's going to be. So really, I find the sweet spot to be here to where you can get to at least the 12 billion parameter right? Which will get you, you really have to get to a 12 gig card to run this. But you can see that that runs pretty close, and so they don't have it in their graph here. Oh, they have a 27 billion model here. The 27 billion model is going to cost you about $750 to $1,000 to get a card that has 24 gigs of memory on it, because as you can see here, it's going to take up 17 gigs, and so the next closest one is either two cards of 12 gig each, or 124s. And so I'm going to talk a little bit more about how I'm building some of these DIY PCs out here. But you can see some of these benchmarks on here with where Gemma 3 scores on these. And, you know, they're showing you even at the 1 billion. But this is why I really feel like this is the sweet spot here, because bang for buck, I mean, but either one of these are really good. And to be able to get into AI for under $1,000 is a pretty good way to start, right? So lots of great stuff there. So what I usually recommend to people do is grab yourself just any machine you have laying around. Generally, if you can have it, it has to have at least one 16x PCIe port, so you can run either one card, or if you want to run two cards, it can also be an economic way, because you can usually get two 12 gig cards right now for around $500, where you can instead buy one 24 gig card, and it's actually more inexpensive to run the two. Now you're going to trade off with a bit more memory usage, so your electricity usage every month is going to be a little bit more, but that's where you really get into it. So any machine that's running with a base 16 gigs of RAM, just so that it can spin up a decent processor, but even those don't really matter. I'm running on something that's about a decade-old processor. So what you usually start with, and this becomes pretty simple, and I even have this in the code sample. So I'm going to switch over to my code sample here, and I'm actually going to switch over here. So if you go to, and I'm going to put the link for this down below, but we have starter pack samples out here, and this is a GitHub repo that we give you totally for free, because we love to train software developers. But this is the basic step, is really you verify Ollama installation. And if you haven't installed Ollama, depending on what you're running it on, it's pretty straightforward, right? If you're on Windows, right, if you just go here to download, if you're on Windows, download the exe, install it. It'll run as a little system tray down here. There's nothing to see here. There's no UI. It just runs in the background. If you run Linux, it's literally this easy to just copy this and run it. Mac, pretty similar as well. Download, install. So any of these are really easy. Once you do that, you start Ollama. So I'm going to show you here at a command line. And the command line that I'm going to be using, so this is the code sample. I've downloaded the code sample, and that README is actually right here as well inside of our code sample. But I've downloaded the code sample here, but I'm just going to use this developer's command prompt here, right? Looks like I already had Ollama running. So here at the command prompt, you can do a couple of different Ollama commands, right? So if Ollama isn't running, the first thing you can do to check and see if Ollama is running is say Ollama, let's try this again, Ollama PS, and this will tell you what it's running. So right now, Ollama is not running. So let's say we want to get it running with Gemma 3, the 12 billion. So you can say Ollama list, and this will give you all the models. So you can see that this is on my streaming machine here where I'm recording these videos for you. So I'm doing this real time, no edits here, but we're, so you can see that I have the Gemma 3 4 billion model on here, because again, this machine doesn't have a huge graphics card. So if you're unsure how much graphics you have, and if you're on Windows here, and you can do similar on others, you can go here to your GPU and see that right now I'm running, it's saying about 3 gigs of graphics, because it uses up one of it for the OS. So, but when I run this here, you can see I say Ollama run, and I'm going to copy and paste because I'm lazy, Gemma 3 4B. Okay, so I'm running the 4 billion model. It does take a little bit to start up here, but now if I were to open up another command prompt and we say Ollama PS, you can see that it's running, so the size of this is 2.9 gigs, so it's running comfortably on my 100% on the, it's saying it's running on the CPU. Let's figure out why we're not running on the GPU here. Probably because the model is larger than I have on the store. So let's actually switch this, and I'm going to pause this really quick and download, because it takes a little while to download. Well, I'll get it started here for you. But so you can see, again, I'm doing this real time so you guys can all see, because we all learned from this, right? So you can see that it's not able to run this because the OS is taking part of it, and this graphics card only has 3 gigs of RAM, 3 gigabytes of VRAM, right? You can see that this shared GPU, dedicated GPU, sorry, you can't use the shared GPU. You have to use the dedicated GPU memory. It's only 3 gigs. So that's too close, and it won't load it in. So this one's running entirely on the CPU, and we'll see if we can figure out why that one is. So let me download the 1 gig model. So what I'm going to do this here is we're going to say buy, and then we're going to say Ollama run. And if we do this, so if you just run it, so if you say run and then you change it to the 1 billion parameter, it's actually going to recognize that it doesn't have it and start to download this. Now this is going to take about a minute, so I'm going to not make you sit here and watch me for a minute while I download this. So I'm going to go ahead and pause this video really quick. So I'm going to keep this real for you here, folks, because this is pretty interesting to me. So this has a 3 gigs graphics card, as we talked about, and the OS always uses about a gig of the graphics card. Anytime you're doing something, your OS is going to use roughly around a gig of it, and I'm streaming and doing this recording and all of that. So I'm using about a gig of graphics. So what's interesting to me is the Gemma 1 billion model, which you can see in the download is only 815 megabytes, but when it actually loads the model up, it's actually loading up at a size of 2.1 gigabytes. So that's kind of interesting because it actually loads almost twice the size. So because of this, it's running on 18% CPU and 82% GPU. So, and that's even on the 1. So really, again, if you're going to get into these, you really got to minimum be really running the 8 gigabyte. And I really recommend even the 12 gigabyte graphics cards to really be running this. Really makes a big difference. But this is my streaming machine, and I'm not set up on my other DIY PC. And because I want to run this code, now I can run this code for you on another machine, but I want to be able to step through the code with you here and show you what we have built. So I'm going to go ahead and do this on the 1 billion, but I highly recommend that the very first thing that you would change is change this to a minimum of the 4 billion at best, because again, it'll even up your context size here, right? That's the other piece of this that gets pretty interesting is, when you're looking at these context sizes here, the 1 billion model only has a 32K context size, whereas your 4 billion and up has 128 gigs. So that's a big difference here, right? So this one's going to make a big difference as you're running on your different context size for how much tokens you can put into the model. And that's really, I find the effectiveness of using these LLMs really comes down to how much you're feeding into the machine to give a good prompt. In our case today, we're actually giving kind of terrible prompts, and this is a really simplified model. So, I mean, this will be okay for our use case today, but just know when you pull down the code, if you want to build this into something real, definitely would recommend the minimum the 4 billion parameter. So you're gonna need at least 6 gig card will run great for the 4 billion parameter. And there's tons of 6 gig cards out there for under $100. So you could take any old machine running around, literally any machine that will boot up and run something, run a latest OS, and then plus one of these $100 cards, and really for even $300 you could get off and running with this model. But $500 really is that kind of sweet spot. So now that we've talked enough about the hardware, let's kind of dive into the code here. So what the structure of our code here is we've broken it down into some main, and then we have the different demos. And so as you can see here, it starts right off with giving you a set of prompts where you can either ask some country information, recipe information, product catalog information, weather forecast, or you can close the app, right? And it just does these. And so the main part of the main is just to kick those off. Now it's going to run each of these different demos accordingly. What this is going to do is going to actually format an object here, which we're going to pass in. Now, I would never generally say, like this is a good code sample, but I would go to an actual model. So you see we have our models down here below for the Ollama message and Ollama response. These are great, but I would generally say format this into a real good model. Don't just pass around objects. That's kind of dirty. This isn't 1999 with PHP anymore. So as you run this though here, you're going to run through and we can see that we're formatting it. We're specifying what model here is. So if you're going to change the model, you're going to have to change the model right here, right? So this is where we change it. We could move this to one of our static read-onlys up on the top. Probably would make sense to do that. But again, this is a code sample. We're giving it to you for free. Enjoy this. The other part here is I would definitely feed in much more of your content of the input, right? This tell me about this. overly simplified, right? But the point here is we're giving the message in JSON format. And that's one of the first things, is it automatically is going to format against the JSON format, right? It's going to know that, hey, we're giving this object format, which even that format is going to be in JSON. And so these will all be in JSON, and it knows to then run this in a JSON format and give you a structured output in JSON. So without further ado, let's get this guy running here so we can take a look. And so we're going to kick this guy up, get it running. Let's see here. Okay, there we go. So let's say we want to start off with recipe information, right? And I'm feeling like recipe name is green chili burrito. Sounds really good tonight. So let's go and get a green chili burrito. Now we're going to hit this, and you can see, I'm going to step into this a little bit. You can see that the format of this is, you can see that the model it's passing here. Here's the message. The rest of this is actually the message, right? The message then breaks down, and you can see, hey, we're going to tell the roles to user. Content is tell me about green chili burritos. Again, you'd want your input on a real agent to be much larger than this. You tell it to stream false. You may want it to stream true. May not. On an agent, having it all process and then come back is probably fine too, because streaming could come with its own, but this is where you would change it if you want Ollama to stream it to you instead of just return all at once. But then we come down to here where we say properties, and this is the recipe name, etc. Right? So this is where it's going to take all of this, format all of our data into it, right? So once we get here, it's going to format this to the content. It's going to send over a response. Now this is going to take a second, because what it's doing here is it's actually sending it over to Ollama, and it's just going to wait until this comes back, right? Because this is an async. So if you needed other processing, but generally I'm like this code sample is good for running as an agent. And generally I would encourage you to build agents where they run in a single Docker container that gets spun up and spun down, right? So that wasn't terrible, even considering this is on a fairly slow machine with obviously not a lot of graphics. And, to our, previous test here, it's running on, it looks like it even moved a little bit. So 21% of this is actually running against the CPU. So it's gonna be a lot faster on something running entirely on the GPU. So we get the response, which then comes back, and you can see this response is in JSON. Now this is huge, because it's going to allow you to take this response and then to be able to break it down and to be able to use this. Now this response here is going to be pretty loose, because you're not knowing exactly what the response model looks like that's coming back inside of it. But you're going to want to break this down and actually pass on the model, and then tell the model, hey, use this and actually send me back in this format. Okay. So, and I'll do a further code sample, a deeper dive on this. But what this then comes back with, as you can see in our model here, comes back with, hey, the recipe is green chili burrito. Preparation time is 20 minutes. Difficulty is easy. Tells you the items you're going to need, and then gives you the steps to break it down and to build your burrito. But you can see that this is all in a structured data format, which allows you to then parse this in your code, and you can actually then pass it in. So what we'll do in a future one here, and I'm going to take this model and continue to extend it a little bit, but our video is already at almost 20 minutes. So I don't want to make these videos too long, but this gives you a great way. Make sure you go and pull down the code samples here, right? Because we love to train software developers here at Startup Hack. You can see this is number 243 of the code samples we have out here. We also have an entire other repo up here that has all of the previous code samples. So if you just go to the home README here, you'll see that there's over 200 previous code samples as well. So we actually are giving you guys tons of free code samples. So, I mean, if I was a new business owner, like to start off, this is a great place to start, where you literally have almost 500 free code samples. Because here at Startup Hack, we love to train software developers in our licensed coding boot camps, as well as to build custom software solutions for companies. So if you need some help, reach out to us at startuphack.com/Spencer. We'd love to help people out. And here's some great information about some of our coding boot camps, and we'll catch you guys next time.
Want to become a software developer but don't want to spend 4 years in college and rack up massive student loan debts? Think you need technical expertise to get started? Welcome to Startup Hack, a better way to start your software career without student loans and years without income. One-on-one tutoring is included, so you never get stuck and have guidance through the whole process. No technical experience is necessary. Learn at your own pace and in your own space. Startup Hack has worked with local state agencies in your area to make it so that qualifying students can get the program costs covered entirely, and students can start earning while they learn.
Startup Hack's .NET Coding Bootcamp was a game changer for my career. As someone with no prior programming experience, I was initially intimidated by the idea of learning to code, but the instructors at Startup Hack broke down complex concepts into easy to understand lessons and provided hands-on projects that really cemented my understanding. The curriculum was comprehensive and up to date and got me ready for my first job. What really set Startup Hack apart was the focus on practical, real-world skills. Thanks to Startup Hack, I landed my dream job as a .NET developer within weeks of graduating. I went from knowing nothing about code to building professional-grade web applications in just a few intense months. If you're looking to break into .NET development or level up your coding skills, I cannot recommend Startup Hack enough.
Complete our 3-month coding bootcamp, gain hands-on experience, and land a paid internship. With 2 years of experience, on average, our graduates are making over $80,000 per year. The 3-month program includes technologies from Microsoft, Google, and Facebook. No debt, just a quick path to earning. Check out startuphack.com to code your future and start today.